right, so practice 3, number 2. We have Bruce, who is a 45-kilogram quarterback, colliding with Griff, a 90-kilogram tackle, who's traveling at 7 meters per second in the other direction. So let's go ahead and start drawing that. As always, first draw your positive direction so that you can define which way is the positive. And then next, we have Bruce. So I'm just going to draw Bruce as a circle. So here's Bruce, and Griff is coming towards him. Bruce is a 45-kilogram quarterback, and he's running at 2 meters per second in the positive direction. Now Griff is running the other direction at 7 meters per second, and his mass is 90 kilograms. So when we graph that, I'm going to go ahead and say that each of these boxes are worth 45 kilograms, or 15. I'll say they're worth 15 kilograms. So let's see, Bruce is 15, 30, 45. So this will be Bruce's line. And Griff will have 1, 2, 3, 4, 5, 6 lines. So this will be Griff's line. And Bruce is traveling at 2 meters per second in the positive direction. We'll go ahead and label these by 2s. So 2 meters in the positive direction. Okay, that's not exactly 2, but it's close. And Griff is traveling 7 in the other. So he's going to be about there, halfway between 6 and 8. All right, so here are Bruce and Griff's graphs. Now, afterwards, they collide, and then they run into each other, and Griff continues to travel in the same direction. So Griff is traveling in the same direction at 1 meter per second. We're trying to find out how fast Bruce was knocked over. So we'll keep the same graph, and Griff will still have 1, 2, 3, 4, 5, 90 kilograms. And now he's at 1 meter per second. And so now I want to make sure that the momentums are the same. So the momentum here, right, is 2 times 45. So 2 times 45 will give us 90. And the momentum here is 90 times 7, which is going to be 630. Now, so then negative 630, because this is in the negative direction, plus 45 should give us the same number for this second graph right here. So now let's figure it out algebraically. We have 45 kilograms for Bruce times his 2 meters per second in the positive direction. And we have Griff at 90 kilograms times negative 7 meters per second. Because we've determined he's traveling to the left, then that will make him negative. And then Bruce, afterwards, we know is still 45 kilograms, but then we don't know his velocity. And Griff, we know, is still 90 kilograms, and now is traveling at 1 meter per second in the negative direction. So when we do our math, we have 45 times 2 will give us 90 kilograms times meters per second, plus 90 times -7 will give us negative 630 kilograms times meters per second. And everything on this side still stays the same because nothing has changed. But now we can go 90 times -1, which is going to be negative 90 kilograms times meters per second. So we simplify it. What we're going to do is add 90 to negative 630. And 90 plus 630, that's negative, will give us negative 540 kilograms times meters per second. And we have Bruce's 45 kilogram times V plus Griff's negative 90 kilograms times meters per second. Now to get the velocity by itself, we'll just do algebra. We'll add 90 to both sides. And we get 45 kilograms times V is equal to 450 kilograms times meters per second. Of course, it's negative. We're going to divide by 45 kilograms on both sides, and that cancels out. And so what we're left with is negative 450 divided by 45 will be negative 10. And then we have meters per second is equal to the velocity. So this means that Bruce is knocked down at 10 meters per second to the left. Or you can also say backwards or whatever means the other direction. So then we'll go back and graph Bruce's. So this is Bruce. So we'll go, Bruce is 45 times 10, which is 450, negative 450. We're going to look at Griff's 90 times -1, which is negative 90. And we have negative 450 plus Griff's negative 90 should be the same as negative 630 plus